Hi, this is GCSE 9-1 Crammers. It's never too late to start revising, and this way you can do it anywhere. Test yourself by stopping the video after each question. Have a go at answering it, then play on to check it. Run through the questions as many times as you need until the answers pop into your head. Today we're revising Physics Topic 1a.3, Specific Heat Capacity, covering equations for specific heat capacity, energy transferred, and power. We will be investigating the specific heat capacity experiment and looking at the differences between specific heat capacity and specific latent heat. What property do all substances have? Specific heat capacity. When energy is transferred from one object to another, a substance changes state, and it will either get hotter or colder. How do you know when a change of state is happening? When the temperature of the substance increases. How do you know when energy is transferred in a substance? When the temperature of a substance changes. What type of energy do all particles have? Internal energy or thermal energy, which is made up of kinetic energy and potential energy. What is the meaning of specific heat capacity? The internal energy needed to raise the temperature of 1 kilogram of material by 1 degree C. What three factors does the amount of energy transferred depend on? Mass, temperature change, and specific heat capacity. How would you find the change in temperature? Final temperature minus the starting temperature equals the temperature change. Equations used: power, energy transferred, and specific heat capacity. After investigating the specific heat capacity of a material and recording the readings from the voltmeter and the ammeter, you can calculate how much power was used in the experiment by multiplying the potential difference by the current. Then you can calculate how much energy is transferred by using the power figure in the energy transferred equation and using the reading of time. Finally, you're now able to find the specific heat capacity of the material using the energy transferred figure you just calculated. So if you're asking, do I need to learn these equations? Well, yes, you do. What is the equation for specific heat capacity transfer? This equation will be given to you on the physics equation sheet in the exam. Energy transferred equals mass times the specific heat capacity multiplied by the change in temperature. Then rearrange the equation to find the specific heat capacity, which is energy transferred divided by mass multiplied by the change in temperature. What is the symbol for specific heat capacity? Lowercase c. What is the symbol for energy transferred? Capital E. What is the symbol for mass? Lowercase m. What is specific heat capacity measured in? Joules per kilogram degrees C. Or use the symbol joules per kilogram degrees C. What is energy transferred measured in? Joules, or use the symbol capital J. What is mass measured in? Kilograms, or use the symbol kg. What is temperature measured in? Degrees Celsius, or use the symbol degrees C. What is meant by the term power? It is the rate of doing work. That is how much work is done per second. What is the equation for power transfer? Power equals potential difference times the current, or P equals VI. What is the symbol for power? Capital P. What is the symbol for potential difference? Capital V. What is the symbol for current? Capital I. What is power measured in? Watts, or a capital W. What is potential difference measured in? Volts, or a capital V. What is current measured in? Amps, or a capital A. What is meant by the term energy transferred? Energy is being transferred around a system. It is the work done by a moving charge, or by a current flowing through a system. Work done is just another way of saying energy transferred. What is the equation for energy transferred? Energy transfer equals power multiplied by time, or E equals PT. What is the symbol for energy transferred? Capital E. What is the symbol for power? Capital P. What is the symbol for time? Lowercase t. What is energy transfer measured in? Joules, or a capital J. What is power measured in? Watts, or a capital W. What is time measured in? Seconds, or a lowercase s. Investigating specific heat capacity. Draw and label a diagram of the apparatus used to investigate the specific heat capacity of a solid material. You'll need to draw a block of material covered in insulation, a thermometer inserted into the block, and an immersion heater. A power supply connected to the heater, an ammeter connected in the power supply to the heater, a voltmeter attached across the immersion heater power input and output. If you're comparing the specific heat capacity of a liquid, place the heater and thermometer in an insulated beaker filled with a known mass of liquid. Explain how to carry out a practical to investigate the specific heat capacity of a solid material. Measure the mass of the block using a mass balance. Wrap it in an insulated layer, for example a layer of newspaper or cotton wool, to reduce the energy transferred from the block to the surroundings. Place an immersion heater into the central hole at the top of the block. Place the thermometer into the smaller hole and put a few drops of oil into the hole to ensure good thermal contact. In the results table, record the initial temperature of the block. Set the potential difference of the power supply to be 10 volts. Turn on the power supply and at the same time start the stopwatch. As the block heats up, take a reading every 10 minutes. Record the reading of the potential difference off the voltmeter and current off the ammeter. Watch the ammeter. The current through the circuit shouldn't change. At the end of the experiment, turn the power off and stop the stopwatch. Record the time in the table. Record the highest temperature it reaches, and remember, there may be a slight delay because the temperature will still rise even though the heater has been turned off and before it will begin to cool, and thermal equilibrium between the heater and the block is reached. Describe the energy transfer that occurs when a block of material is heated using the equipment. Turning on the power, the current in the circuit is a moving charge. Electrical energy is transferred from the power supply and does work on the heater, transferring electrical energy to the heater's thermal energy store. Then the thermal energy is transferred to the thermal energy store of the block by heating, causing the material's temperature to increase. You can calculate the power of the heater by using your measurements from the experiment, using the equation power equals potential difference times current, or P equals VI. Power is measured in watts, potential difference is measured in volts, and current is measured in amps. You can calculate how much energy is being transferred by the heater at the time of each temperature reading using the equation energy transfer equals power multiplied by time, or E equals PT. Power is measured in watts, energy transfer is measured in joules, and time is measured in seconds. Describe how you would use the apparatus to determine the specific heat capacity of a block of material. This would be a 6-mark question, so what are the examiners wanting you to include in your answer? Explain how to find the measurements needed to calculate the specific heat capacity. Give the equation to calculate the specific heat capacity. Explain how you would use the results from the experiment. And finally, state a safety point. Explain how to find the measurements needed to calculate the specific heat capacity. Calculate the power of the heater using the readings from the ammeter and the voltmeter, using the equation power equals potential difference times current. Then calculate how much energy is being transferred by the heater, using the equation energy transferred equals power multiplied by time. Find the mass of the block of material using the mass balance. Find the temperature change using the thermometer from taking the final reading and subtracting the initial reading. Give the equation to calculate the specific heat capacity. Use the equation energy transferred equals mass multiplied by specific heat capacity multiplied by temperature. Then rearrange the equation to find the specific heat capacity, which equals energy transferred divided by mass multiplied by the change in temperature. Plotting the results onto a graph of energy transferred to temperature stored in the material of the block. It should look something like this. You may or may not get a curve like this at the beginning, so don't worry about it. Find the gradient of the straight line part of the graph. The gradient equals change in temperature divided by the change in energy transferred. Find the change in temperature by looking for the final temperature reading on the graph and subtract the initial temperature, and use this figure in the gradient equation. Then find the change in energy transferred, again by looking for the final energy transferred reading on the graph and subtract the initial energy transferred figure and put the answer into the gradient equation. These figures are in the equation. Energy transferred equals mass times specific heat capacity times temperature change. Once you've calculated the gradient, you use that figure in the equation. 1 divided by gradient times the mass of the block to find the specific heat capacity of the material of the block. You can repeat this experiment a number of times and calculate the mean of the results to get a more accurate result. State a safety point when carrying out the experiment. Avoid touching the immersion heater with bare hands once it's turned on, because it's very hot and you'll get burnt fingers. What changes could you make to this experiment to make it work better? Preheat the immersion heater so the change in temperature stays constant. If the size of the hole in the block of material is a lot bigger than the thermometer, pour a small amount of water or oil into the hole. Rub some Vaseline around the base of the thermometer to stop any air getting between the thermometer and the block and to insulate the thermometer from the air, resulting in more accurate temperature readings. Wrap insulation around the block of material to prevent heat loss. Explain why some methods used to determine the specific heat capacity of a block of material may give a value greater than the actual value. Some thermal energy may be transferred to the surroundings and not into the block, so the temperature increase will not be as high as it should be for the total energy transferred by the heater. Tackling equation questions. Each day the average European family uses 100 kilograms of hot water. To kill bacteria, the water going into the tank at 20 degrees Celsius must be heated to 60 degrees Celsius. Calculate the energy needed to increase the temperature of 100 kilograms of water by 40 degrees C. Specific heat capacity of water equals 4,200 joules per kilogram degrees C. What does the question tell us? The mass of the hot water is 100 kilograms. The change in temperature is 60 degrees C minus 20 degrees C, which equals 40 degrees C. Specific heat capacity of water equals 4,200 joules per kilogram degrees C. And finally, we need to find the energy transferred. The equation for energy transferred is mass multiplied by specific heat capacity multiplied by temperature. Substitute the figures 100 multiplied by 4,200 multiplied by 40. Do the maths and it equals 16,800,000 joules. Differences between specific heat capacity and specific latent heat. Make sure you don't get these mixed up. Specific heat capacity is the internal energy needed to raise the temperature of 1 kilogram of material by 1 degree C, whereas specific latent heat is the energy needed to change the state of 1 kilogram of a substance without changing the temperature. Specific heat capacity transfers heat from one system to another, whereas with specific latent heat, the energy goes into breaking bonds or making bonds that hold the molecules together. That is why there's no change in temperature. The key to exam success is learning, consolidation, and keeping this topic fresh in your mind to nail those questions in the Physics GCSE Paper 1 exam. If you go over this enough times, you'll be able to answer any questions on this topic confidently in your exam. This is GCSE 9-1 Crammers, and if you like the content of this video, give us a thumbs up. And if you have a question or need help, give us a comment below. And don't forget, smash that subscribe button if you want more Crammers videos for your exam success. Thanks for watching and see you again soon!